Students, good morning. Today I am going to discuss about the heat effects accompanying chemical reactions. Heat effects accompanying Before entering into the discussion, just we have to recollect several points. What is the chemical reaction? Chemical reaction is a process in which reactants are converted into products. Reactant are converted into products, useful or desired products. Clear? What is going on there during this process? During this process, the bonds between the atoms or molecules of the reactants gets breakdown, breakup of bonds. Breakup of bonds between the atoms or molecules of the reactant. Similarly, during the formation of products, there will be a formation of bonds. Formation of bonds between the atoms or molecules in order to constitute the new compound. New compound means product. This is happened during the process. In this process, reactants are converted into product. This is called as chemical reaction. Right. During the breakup of bonds, definitely there will be an exchange of heat. Either you are going to add heat or certain amount of heat can be evolved. Similarly, during the formation of products, again heat can be added to the system or heat can be removed from the system. So, involvement of heat effects. Heat effects. So, heat effects are energy changes involved in the course of chemical reaction in which a certain amount of heat can be absorbed or certain amount of heat can be liberated. Heat absorbed or certain amount of heat evolved. Heat evolved. Absorption of heat, the reaction in which absorption of heat are called endothermic reactions. Endothermic reactions. Evaluation of heat during the process or during chemical reaction, the reactions are called exothermic reactions. Exothermic reactions. Hence, the knowledge on heat effects accompanying a chemical reaction as well as the influence of experimental parameters on these heat effects is very much essential in order to provide a proper design of the process vessel. Process vessel means reactor. For the better or proper design of the reactor and its operation, we should know the sound knowledge on heat effects accompanying chemical reactions. For better understanding, let us consider a simple neutralization reaction. Neutralization reaction. The reaction is sodium hydroxide will react with hydrogen chloride to form sodium chloride and water. This reaction we often use it for acid-base titration. In this reaction, the base is neutralized by using a acid-base titration. We often use it in our laboratory for acid-base titration. Right. What is going on here during the reaction? When 1 moles of NaOH react together with 1 moles of hydrogen chloride, before reaction, the bond between the reactant, that means Na plus OH minus, gets breakdown. Similarly for HCl, H plus Cl minus. Before proceeds for the reaction, bonds should break up of bonds. Clear? Right. Next, formation of the product. For formation of product, Na plus Cl minus. This is the constitution of the compound. Constitution of the compound. This is formed by Na plus Cl minus. Similarly, formation of water, H plus OH minus. This is formed by this one. What I am trying to say is, during the breakup of bonds, it requires energy. It requires energy. During the formation of new compound, it releases the energy. It releases energy. Amount of energy released in this reaction is much greater than the amount of energy required. Hence, the net effect is release of energy. This is the exothermic reaction. This is the exothermic reaction. That means it has a negative enthalpy. For this reaction, changes in enthalpy is equal to minus 57.1 kilojoules per mole. So this is the basic knowledge. What is going on there when a reaction happens? So this indicates during this reaction, this much quantity of 57.1 kilojoules of heat released for formation of 1 mole of water. This information says you have to provide a proper arrangement to remove this heat from the reaction vessel. Clear? Right. That is a simple calculation. Say for example, take 1 molar solution, 1 molar NaOH solution. Similarly, 1 molar HCl solution. 1 molar solution means 40 grams of sodium hydroxide will dissolve or used to prepare 100 ml of a solution. Molarity means moles of solid divided by volume of solution in liter. 40 grams of substance is used to prepare 1 molar of solution 1000 ml. Similarly, 58.44 grams of sodium hydrogen chloride substance is used to prepare 1000 ml of solution. Take 1 molar NaOH, 1 molar HCl. Say for example 50 ml of NaOH plus 50 ml of HCl. What about the operation? Take this solution in a beaker. Take these two solutions in a beaker. Definitely you will feel a warm or an increased temperature of the beaker. While you insert the thermometer, it sends certain increase in temperature. Right. 50 ml of 1 molar solution. What about the amount of substance present in it? So for example, 50 ml, 1 molar solution is 40 grams divided by 1000 ml. So this will be certain amount of grams dissolved in the substance, converted into moles. Okay, converted into moles. Use certain thermometer. Use a thermometer to measure the temperature. 57.1 kilojoules per mole. How much substance is prepared? Mole basis is known. Calculate the amount of heat released during this 50 ml of 1 molar solution and 50 ml of 1 molar HCl solution. This calculation provides 2.86 kilojoules of heat will be evolved during the reaction. 2.86 kilojoules of heat evolved from the reaction. What about the rise in temperature? This is Q. Q is equal to mCp dt. mass 50 plus 50 100 ml, density of water is 1, hence 100 ml is equal to 100 grams, 100 ml is equal to 100 grams or 0.1 kg. So mass is known, Cp of water 4.184 kilojoules per kg degree Kelvin, and remaining thing is changes in temperature. So you calculate this one, the changes in temperature near about 6.8 degree Kelvin or 7 degree Kelvin. If a proper insulation is provided in this process vessel, there will be increase in temperature of 7 degree Kelvin or 7 degree Celsius. So this is the fundamental information. So knowledge on heat effect is very much essential for the proper design of the reaction vessel. That means process vessel means reactor. Proper design and its operation, because the influence of experimental parameters will play a vital role to change this or to affect the process design. This is the simple information or principles behind the heat effects accompanying chemical reactions. Thank you.